Jonathan, you mind if we present the drawings and go over them?
So we take a quick look.
So really see if I can make this work, right?
Yeah.
You start with the overall diagram.
So we'll start with...
That's the battery. No, that's the...
This is specifically to do with the alternator.
All right, I'm going to...
Alternators, should I say.
Ah, yes, that was one of the... So I could do that.
Put that out the way.
All right.
So
what are we looking at here?
this is a electrical schematic of specifically the way that the alternators... So the alternators are part of the engines. The engines, of course, are, propelling the vessel through the water. So while they're doing that and they're running anyway, the alternators are producing electrical power to recharge the battery system. And this schematic just basically gives us the drawing of how those alternators are integrated into the battery system using a special regulator, which is made by a company called Wakespeed. And these regulate the output of the alternators so that they charge the lithium appropriately via the BMS and the distribution system over here, where all the heavy gauge wires are feeding that charge into the battery system.
So these effectively act by going to a 48 volt system as generators on each one of the engines.
Correct, yeah. You can see an alternator is pretty much a generator at the end of the day, and the way that we did this vessel is a 48 volt system. We chose 48 volts because it's more efficient than traditional 12 volt systems on boats. And these alternators are specifically 48 volt alternators. And therefore, because of the voltage being a higher voltage, the wire size reduces, making things a little lighter, a little easier to work with. And, you're getting a significant amount of charge from your engines while you're using them. So it's kind of a no-brainer to make sure that you use that engine power to charge your batteries.
This is, as soon as I turn on the engines, we're over 2K in each one of the alternators, and then by peak running cruise, we're close to 13,000 kW, or 13,000 watts, so 13 kW.
Yep.
Yeah, it's pretty efficient.
Yeah, so that's a great addition, especially being a power catamaran. You're using your engines to get around. So every time you move from one anchorage to the next or dock to dock, you're charging your batteries right off your engines.
Yeah, so very, very elegant solution.
Yep.
You got basically a battery management system for the batteries. You've got a
regulator
that regulates the current or amperage into the system so it doesn't overload.
Yes.
And then you have the alternators that are running based on the RPMs or how much fuel you push to the engines to move yourself along.
Yeah, basically they are being propelled or, running due to the engine spinning, and there's a belt that keeps the engines cool, and that belt is spinning the alternators and creating the charge.
Right, just like a motor on a car.
Yeah.
But this happens to be a diesel engine. So what is this right here?
Over there is the servo, which is basically a black box little computer, the brain of the monitoring system. So connected to this device is a 7-inch touch screen, and we maybe show you that later in another video as we maybe walk through the system. And this basically takes all the information via network and converts it to usable data on your display.
So by network, this is basically a computer.
Yep.
And there's a network of parts and pieces on the boat, this being the battery management system, this being the regulator, and then there's the alternators. What about these? Those is here.
Those are called shunts. A shunt is a device that is there to give you how much current is flowing through the system. So it is normally installed on the negative ground wires, and ultimately it is going to tell you, there's 200 amps flowing or there's 100 amps flowing. It's a part of the monitoring system to give you valuable and useful battery information.
That acts as a fuse as well, right?
No, that doesn't act as a fuse. There's going to be an independent fuse in the battery management system. So you can see 150 amp and 150 amp fuse per alternator.
So in case there was a spike or malfunction here,
yes,
the battery management system will blow the fuse.
Yes.
So this is more to say, hey, all is good.
Yes. It's just providing information to the system about how many amps are reaching the batteries so that ultimately that's going to give you your information regarding state of charge, how full your batteries are. Are they 80%, 90%, 100%? They need to know how much current has reached the batteries, and these things, the shunts, ultimately provide that information.
Very cool. Shall we go to the next drawing?
Sure.
All right, so what are we looking at here now, Jonathan?
This is the AC distribution drawing. So AC being alternating current. That is the same as what you generally find in your residential homes and so on. Your outlet that you plug your laptop into, etc. That's 120 volts. That is alternating current. So this is the alternating current side of things on the vessel. And over here, we have got really pretty much some of the most important components of this entire system are the two Quattro inverter chargers. These two devices are capable of producing 10,000 watts of power each, and they are wired in parallel, giving us a total of 20,000 or 20 kW of inverted power for the boat.
So that's alternating current,
It's
right, from DC current or alternating current. So the boat has, as a holistic system, has options of traditional powering,
shore power. Yeah.
and that would be a 50 amp, 120, 240 volt, similar to what a house would have, coming in from the grid,
From the street. Yeah.
right?
Yeah.
So we can tie into that, and we can tell the system, okay, there's shore power available.
Yep.
So start using the shore power, right, to either to power the batteries or to run all your electronics, right?
So basically, the shore power when you plugged in, or we also have a generator up on board the vessel, which is also providing a alternating current to the vessel.
That's a good point. And that's the traditional solution, right? You turn on your engines, and if you want air conditioning or an oven or watch your, anything else that's big consumer like a washer and dryer, you need to run your generator if you're not tied on the shore.
Yep, exactly. So generators are noisy. They use diesel. They're not very environmentally friendly. So, part of the solution here is that we limit how often the generator actually needs to be run by utilizing inverted power when we're not plugged into shore power or not running the generator.
From the battery.
Yeah. Inverted power meaning that the batteries are taking the 48 volts DC direct current, passing that to the Quattros. The Quattros are then taking that 48 volt DC and converting it into 120, 240 volt alternating current, which then can run your traditional things like washer dryers, air conditioning, and so on.
So what's this?
This is the auto transformer, and basically the auto transformer is there specifically to, it's just really there to kind of clean things up a little bit and put out the exact voltages that we want. So
To make sure we don't overload the system or create a draw that blows fuses.
Sure. In some ways that's correct. I mean, its main purpose is basically to take in from shore power generator or the Quattros, it's going to take in the power and it's just going to put it out in a cleaner format, and that we know that we're getting the correct 240 or 120 for the different loads. As you can see, we got 230 volt loads and we got 120 volt loads and another 120 volt loads. So it's taking in the 240 and outputting 120, 240 for the different.
And the biggest consumer would be the airtime.
Yes. So the aircon,
why that's such a big consumer and why you have that separated in the draw.
Yeah, sure. So the air conditioning, this boat has a chiller plant that is producing the necessary cooling for the handlers throughout the boat, that is cooling the boat, and especially down here in South Florida, if you spend any time here in the summers, you need a good air conditioning system. So the air conditioning system is your biggest consumer on the boat during hot days. And as you can see, we are going to those separately because they are straight 240 volt devices, and you can see the gen set can feed those as well, and Shore 1 as we have a bypass set up here as well.
And that's all seamless, automatic, based on the system, which would be the servo.
Yeah, well, so basically the Quattros will determine if there's shore power or generator. basically generator is priority. So if there is generator power available, they're going to pass that through. If there's shore power available, they're going to pass that through. If neither are available, they automatically switch into the invert mode and make a seamless transfer. So when you say shut down your generator, immediately the inverters kick on and your air conditioning doesn't shut down or anything like that.
And that was a lot of custom relay work and design based on the intent of how you make this seamless.
No, with the Quattros, that's all built into them, and it's part of the Victron Quattro system. They automatically detect and make those decisions and changes by themselves.
Okay.
Where we kind of engineered here was that we created a bypass scenario. The most likely thing to fail in the system, to be honest, would be one of these Quattros. And if you were to lose these and we didn't have any way to bypass them, you're basically dead in the water. So we have created two bypass options, one being this vessel originally had two shore power inlets. So we've created one of those shore power inlets is now a bypass option. And there's some selector switches on the main distribution panel that just need to be reorientated to allow the shore power to basically bypass the two Quattros and feed everything directly. And we also have a second bypass is if you're not on shore, the generator can also be bypass the Quattros and just feed the vessel. So we've given Curtis two great bypass options here if he were to have a failure.
And would you call that redundancy on the boat to ensure that we can safely operate if in the event something happens?
Yeah, it's great redundancy. You know, it's a boat, you're on the water, something goes wrong, you generally want a backup of some kind. And I think it's one of the things that Maz Ocean really prides themselves in is that generally when we do a lithium system, we create some kind of bypass feature so that, you know, if there is a failure, the vessel can continue to operate pretty much as normal.
Now, what happens if one Quattro goes down?
Well, in this situation, because they are parallel together, ultimately it will cause the entire system to shut down. You can ultimately, with programming, so you got to plug in with the laptop, you can disable the one and set things up again to operate only off of one, but you're only going to have 10,000 or 10 kW of inverted power.
With the system that we have on board with Starlink, if I get it powered up, can you do that remotely?
Yes, we actually can do that remotely. As long as it's not completely dead. Sometimes with one of them failing, as long as it's still communicating, we can probably get online, reconfigure everything and get everything reworking with just one inverter remotely. That's the beauty of the servo that we were talking about, the brain, the computer, is as long as it's connected to the internet, it gives us, Maz Ocean, the access via a portal to get onto the boat, see what's going on, make some programming changes, do updates and all the like.
And that was relatively just a couple of years ago that they were able to do that. I think we had talked about that originally and said, yeah, we can make it happen.
Yeah.
Yeah.
No, it's very new, the whole being able to remote in and actually access equipment and make changes. You know, yeah, sure, previously you could have maybe team viewed into a boat, but you wouldn't have really been able to, you know, do anything with that.
You could literally log into the system with the privileges and manipulate the system. You can turn it on and off. You can effectively turn on shore power. You can turn on the generator remotely. In fact, we programmed also a system that measures the battery capacity, and if it falls below a certain level, it automatically turns on the generator if it's set up for that.
Yeah, correct. I mean, that's once again the beauty of technology is the ability to access and control most of this remotely from a cell phone, iPad, tablet, or any PC. And then, as mentioned by Curtis, we've also created if you're off the boat and the batteries reach a certain level, we've set up a system that will kick the generator, start the generator automatically so that it charges up the batteries without you even having to think about it.
So you've got through two parts of the system. Let's go to the next.
Sure.
Right. So what are we looking at here?
Right, this is the schematic for the direct current DC side of things, which includes all the batteries. So as you can see over here, we installed 12 of the MG 280 amp hour batteries. They're giving us really a massive battery bank on this boat.
Those were 24 volt
correct
batteries that we wired together in pairs, right? Or
in
series
series, yeah,
to create a 48 volts
system.
battery system, and there's 6 of those, or 12 batteries
Volt. Yep.
for 86 kWh and 86,000 kilowatt hours worth of battery capacity.
Yeah. Which, as I said, to be honest, probably it might be the biggest battery bank that we've installed to this date, or very close to one of the largest, giving Curtis the ability to really be off grid. As we
For the size of the boat, this is one of the largest that you've seen.
Yeah, no, for sure. For this vessel size, and Curtis was talking about off grid right in the beginning, and by having this much battery capacity, we really are creating that platform that is even an option and a possibility. And we'll talk solar in a second, because that's making that all work.
And effectively running everything, we're about 72 hours before we really need to recharge.
Sure. Yeah, you've spent some time on the boat now since the system's been completed. And I think as we move into the summer months here, that may increase on good, long, sunny days because of the also significant solar.
Especially as we go further north where the days are longer.
Longer days, yeah, more so.
So let's continue. So the battery banks is really sort of the storage for the electrical system to consume from, right? So how do we get the power?
So basically, we talked about our 2 Quattros earlier. So those are your big chargers as well. They're inverters and they're chargers. So when we do have generator or shore power, your Quattros are putting in a huge amount of charge during that time to charge the batteries. That's one of the reasons we also went with 2 of these, is it reduces when you do have to charge via generator. It reduces the runtime on the generator significantly, because they can push a huge amount of charge into the batteries and charge them up very quickly.
We have that at about 10 kW, 50 amps, 10,000 watts of input.
Yep.
Regulated by the BMS, right?
Well, the Quattros do the regulating of the charge, and the BMS is just communicating with the Quattros. Battery management system, saying, good, send me charge. I'm ready for some charge, or hey, I'm almost full, slow down. I don't need as much charge.
So what are these? So these are the main fuses or shutoffs.
Battery switches. So just for service reasons, when you do need to service the Quattros for any reason, these are cut off so that you are disconnecting the batteries from the Quattros to safely then open things up and actually make any wiring adjustments or changes.
How would I know that there might be an issue, right? We go to the servo, it sends a fault alarm.
Correct.
To let me know that there might be an issue.
Yeah, like low battery voltage. If for some reason the solar hasn't been doing its job and you haven't run your generator for a few days and you're not paying attention, you're going to get a notification that, hey, your battery voltage is low and it's time to turn on the generator. And so that's going to give you a lot of information in terms of alarms, alerts, and notifications as well.
So what are these?
These are basically just called distributors, and basically they're just big bus bars, and basically just combining wiring together in a clean and attractive way. And they do have fuses inside of them. As you can see, 200 amp times 4. So we got 8 200 amp fuses over here for the batteries. For the Quattros and for the solar system.
So that is basically the protection for the main distribution of this.
Yes.
And basically a big fuse.
Yes.
Or series of fuses.
Series of fuses. There's 4 fuses per module.
Now, does that communicate with the battery management system, or?
These are not particularly smart. The only thing that they do is there's one little wire that jumps between them that gives you a red LED if a fuse were to blow. So it just makes troubleshooting simpler.
Something's gone on.
Yeah. So
where do we go from there?
So basically, this is the load and the charge side of things. So the distributors, we have 2 more distributors, or links power ends in this case, that are where the batteries come in, and the BMS sits in between everything. So you got the battery side of things, batteries, your battery management system, you got your charge, so solar, Quattros, alternators, and then load. Load being things, all the DC stuff on the boat. Although in this situation, because this is the 48 volt system, we're not really running any DC loads here. It's really main purpose is to invert and run
And that was a conscious decision on both of our parts, right? To say, hey, we've got a 12-volt system. Let's leave that wiring and that system alone. It has an 800 amp hour set of lithium iron batteries as well. And that can pretty much be off grid by itself for about 7 days because of the large battery bank that usually would run a couple hours and be drained down by the AC side originally on the boat.
Yep.
Right. So we've gone through the inverters, right? The battery management. Just to point out, typically you wouldn't have a whole battery bank split into two. Why did we do that?
Space. Well, basically, it's not really two battery banks split into two. We got 6 batteries in the port side hull and 6 batteries on the starboard side hull for weight distribution and just in terms of where we could locate the batteries. But ultimately, it is one big battery bank. But just the way it's drawn out is just because of the way it is laid out.
It was laid out on the boat. It was the starboard hulls.
Yes.
And we wanted to balance it and get the center of gravity as centered and as low as possible. And that's why the diagram shows it as being essentially split in two.
Yep.
Right?
Correct.
Now, what is this?
That is the MG display. Because we utilized MG batteries, it's the manufacturer of the batteries. They have a dedicated, their own little display. Very similar to the servo display. It's part of this system, gives you a lot of the same information that the servo display does, very specific to the batteries.
So it just tells me the health of the batteries and making sure everything is balanced.
Correct. Balanced batteries, fully charged batteries, voltages, amperages, etc.
Now, there was an important part when we made the conscious decision to do this about the wiring and the voltage drop. So we were very careful to make sure that we had matched the lengths of the cabling so that they were as close to the same or mirrored as possible.
Correct.
To maintain the balance
of the
batteries.
Yeah, one of the things with lithium is cell balancing. So inside each battery, there's a number of cells. Those cells need to be balanced with each other. Lithium don't like to get unbalanced. And the one way to make sure you achieve that is from each battery to the distribution over here, these wires are identical in length. Because if the wires were different in length, then you've got different kind of resistance in the wires, and that could affect the cell voltages inside the batteries and cause problems.
Am I correct in saying that's voltage drop that you want to be very careful with?
Correct. Yeah.
So that's the practical application if you're going to do this yourself, that you really need to have that knowledge base and understanding.
Yeah. So voltage drop based on wire length is important, but then also voltage drop based on wire size in terms of the gauge, how thick the wire is also a massive factor when you're doing DC side direct current wiring. On the alternating current side of things, yes, wire gauge is important, but its length of the wire is irrelevant up to a certain length.
Versus what the DC.
Versus the DC, you know, there's calculators out there, ABYC, we talked about earlier, American Boat and Yacht Council, have a table that tells you if you want to run a wire 50 feet, and put 20 amps through that wire, you need to use, for example, that might be like a 1 gauge wire. So you need to pay a lot of attention to wire sizing, because one of the biggest things on boats is boat fires. Most boat fires occur due to electrical reasons, and that's often because of undersized wires, because imagine taking water and trying to push a whole bunch of water through a really small hose, and it might make that hose explode.
Or melt, in this case.
Yeah, with electricity, similar concept. You're trying to push more electricity through something that's too skinny, and ultimately that results in heat, which results in fire.
Okay, so let's go to the solar side, right? This is a lot of solar for a 44-foot boat.
Yeah. I mean, big solar array on this boat, and as we've been talking, you know, we went really big here to make sure that we can keep this boat charged up with the solar as much as possible, reducing having to run that generator. So as you can see, we have a total of, 14 panels.
540 watt glass on glass, bifacial panels. So each in combined, all 14 is over 70.5 kW or 7,500 watts of solar potential production. You know, we've reached a maximum or peak of just over 7,000.
Nice.
But and that's rare, right?
Yeah.
I mean, just because you have 7,500 watts of solar panels potential doesn't necessarily mean that you can get that kind of power from it.
Yeah, exactly. I mean, the fact that you have seen over 7,000, especially most of the monitoring has been done through the winter here. So as we move into the summer months and we start seeing, you know, that peak sun noon on a hot sunny day, direct overhead sunlight, you know, we're going to see massive improvements potentially on that. And you might even get over the anticipated 75 because it's bifacial panels.
We're going to find out.
Yeah,
Let you know.
Yeah, with bifacial panels, not only are you getting sunlight on the top of the panels, but in this boat, you're getting reflected power, you know, off of the decks or off of the water is coming and producing power on the underside of the panel.
Solar manufacturer indicates it could be at maximum point that they've tested upwards of 30% from the secondary surface or bifaciality.
Yeah, so that's going to potentially produce a huge amount of additional power as well.
So we go from the panels. Now, why are they tied together in two?
So basically, we've tied panels into series pairs. Basically, by seriesing panels, we're increasing the voltage. By increasing the voltage, we're reducing the wire size required. And that just makes it a little easier. We would have had to run, if we just did each of these, all of these in parallel, the wire sizing would just have been needed to be bigger. And also just the higher the voltage, the more efficient things are.
It brings a good segue to what are these? These are 70 MPPT controllers. What is an MPPT controller?
Basically, what an MPPT controller is, your device that regulates what's coming from the solar. So, you know, we may be getting, say, with two panels tied together in the 80 to 100 volt range. So nice high voltage, efficient voltage. It's taking that 100, say, volts, downgrading it to 48 volts appropriate for the lithium, and then passing them back onto the batteries. So basically, these devices are there to control what the solar is doing and how it's reaching the batteries.
You know, typically you don't see this many MPPT controllers. Why did we do that?
Well, once again, redundancy and just shading reasons. You know, the more MPPTs you have, the more likely you are to produce power. You know, we could have wired 4 in series if we wanted to, but then say 2 of them were to get shaded, it could bring down all 4 of them. So by having more MPPTs, we are ensuring that, say, these 2 panels are shaded, it's not affecting any of the other panels.
So we're optimizing the efficiency based on using more MPPT controllers to ensure that we have the maximum production. And also, if one goes down, you don't lose half of your system.
Sure. I mean, as I said, you could have wired, say we could have done 4s, or you could even do 6, or you could have done 6 in parallel. There's various ways of configuring solar, but
this, I believe, was MPPT 150/35.
Yeah, I think it's...
So the 150 is the 150 volts, and the 35
is the amps. Yes.
Right? And it happened to work out really, really well, because this was about 100 volts, or just, I think, a little bit more, 102 volts combined, right? And this is about 66% of the capacity of the MPPT controller. So you don't want to be... You don't want to max it, right? Mm-hmm. What is the service load? Typically 80% that you sort of aim towards, or something to that effect.
Yeah, I'm not really sure on that. Yeah.
Well, but this is not overloaded, right? It's within that kind of sweet spot of production, basically.
Yeah, we didn't want to do you can do a 130, you know, and if we were like right there, like 95 volts, and we used a 100, if for some reason we went over that 100 volts, surged or something, you're going to damage, or it's going to shut down and stop operating. So, you know, finding, as you said, that sweet spot of about 80%, you know, is generally for like generators and stuff load-wise, you know, what you want to be dealing with.
So there's a couple other components here, right? So what is this area here?
Well, this was the first drawing we looked at, the alternator side of things. So you got your wake speed regulators, your alternators that are then also allowing and helping charge batteries when the engines are running.
So that really is sort of the alternate system of not the generator and not shore powered.
And not solar.
And not solar.
So, once again, it's a power boat. You use your engines, might as well use them to charge your batteries at the same time. And that's where the
And if the batteries were low, when we started out, you would be producing solar and you would be producing power from the alternators or the generators that are hooked onto the batteries.
Correct. Yeah. I mean, you could, if you were running, which we'd have to do the numbers, but if you were to start your engines, be running at cruising speed, these are going to be producing potentially up to 130 amps each, plus all the power that you're getting out of the solar, which will vary depending on the time of the day and how the sun is. You could also then kick your generator on, and your two quattros could also start to charge the batteries. But now we start dealing in numbers that are pretty insane in terms of how much charge we're putting to the batteries.
And I ran the numbers. So in theory, if I had the solar panels running at full tilt, let's just call it 7,000 kW, and at 130 amps, 48 volt, these run max charge at about 13 kW or 13,000 watts.
Is it?
Just right there, that's 20,000 kW or 20,000 watts or 20 kW. And then the generator that we have on board is 8.9. So let's just call it 9 kW. So we're just
Under 30
kW.
Yeah.
Not including any inverter power.
Yep.
Right?
Yep.
That
So
would be shore power. So at some point in time, though, you're controlling with the servo system saying, wait, that's way too much power.
Exactly.
You'd be controlling maybe maximum 20 kW.
Yeah. I mean, that's where you would, I don't think you would ever, if you're running your engines and you've got solar working, you're ever going to turn your generator on. You don't need that kind of power.
Right.
Yeah.
And within, let's say, 2.5 hours of cruising, right, typically we're at full charge back up again, right, from about 20%, right? So what happens when that happens? You've got controllers here, you got a BMS here, you got the MPPT controllers, right? What happens when the system does get approached or becomes fully charged?
Then all the devices, the regulating devices, your alternator regulators, your MPPTs for solar, are all going to be told by the servo, basically, that, hey, I don't need any more charge, and then they will down-regulate or regulate the output of all these alternators and solar so that we're not going to overcharge the batteries. So battery safety is important.
So it's a comprehensive sort of solution, right? And let me shake your hand. You did a great job on this.
Thanks.
Yeah.
Appreciate it.
All right, shall we take a look at the servo system right now?
Sure.
Jonathan, what are we looking at here?
This is the display for the servo that we discussed earlier. So basically, the servo is the brain of the system, and this is the display. Basically, as we said, it's a little computer providing all this information to the touch screen over here. And if you look at the screen over here, it is basically showing us currently that we have, in this area, it would either tell us that there was shore power connected or generator connected. Currently, we got dashes, meaning there's no shore power or no generator running or connected, meaning that we are inverting right now. So that means we're taking power from the batteries and converting that 48 volt DC to the 120 240 volt alternating current.
So it's just went from over 5,000 watts of solar down to 25 because there's the cloud. It just came out.
Yeah, some shading just happened. So yeah, we just got a little bit of cloud cover. So that's talking about that. You can PV charge, PV being photovoltaic, meaning solar, giving us the numbers that we're getting right now from solar.
And then the AC loads, that is all the loads that we're pretty much running right now.
Yeah, so that's going to be air conditioning is probably a part of that. I don't know if the hot water heater is possibly on and using some of the power,
Got
etc.
pretty much everything going on the boat, right?
Mhm.
Whether it be the
Yeah.
pumps, whether it be
Yeah.
the air conditioning, or
Yeah, if you were to turn the stove on because it's an induction cooktop,
Yep.
that would increase, etc.
and it's charging on the.
How are you?
Good, and you, thanks.
Good to see you.
And you too.
I'm gonna run out here. It looks like our cushions are coming.
Yeah,
Yeah.
very cool. All right, so we got 40% capacity right now, and I can probably bring the other my iPad over to show the history, right? Once you keep on going through, so what we're seeing? It went to the lines were going and charging at one point in time. Now they're going out. So what's going on there?
So basically right now, because there is insufficient sunlight because of the cloudiness, we're using battery power and solar power to the inverters to produce the AC alternating current power to run air conditioning, etc., etc. Once the sun kind of comes back out here, we'll probably see this increase, and then we should start to see some of that solar power reaching the batteries. In my opinion, the most important part of this entire display is this bottom left corner. It gives you all your battery information. State of charge, 40%. What your discharge rate is currently of, minus 15 amps or 750 watts, and what your voltage is. This is, for me, the most important part of the puzzle. Yeah.
Now that also is here.
Yes.
Right? This is the MG, the battery bank system, and
Yep.
it shows but you can really drill down
Into each battery.
each battery all the way down to the cells. And
Yeah.
it shows whether there's been an event. It shows that the communication's on. Right? So that in combination there is pretty much all of the information running on the battery bank system.
Battery bank and your general electrical system.
Yeah.
It's not just batteries, it's also how many loads, etc., etc.
Now, here, if we hit menu, right, what are we seeing there?
So this is basically, if you want to call it a device list, it's listing all the equipment that's part of the system and gives you certain control. So we can go into the quattros, which are the inverter chargers. We can go and make certain changes here, like if we are tripping our shore power breaker for some reason, we can reduce the current that we're going to be pulling from shore. We can turn things on and off from here. There's an option to turn things on and off.
Why don't we do that so they can see just how simple it is? And I'll show them the remote system.
Yep.
So let's put it on, right? It immediately goes back to, it wasn't inverting now. Now it senses.
Yeah, it takes about 20 seconds, and it's going to then go to bulk, meaning it's detected there is shore power available.
Yep.
It's now going to take that shore power, pass it through to run air conditioning and everything, but then use it as well to create charge for the batteries.
Right.
So if we now go back to our pages, we'll now see we have got positive 151 amps or 8,000 watts of power reaching the actual batteries. So solar coming in,
And
charger coming in.
and we're consuming at this time 3,500 watts of electricity.
Yes.
So that's like a small house,
Yes. Yeah.
right? Or an apartment.
Yeah. An apartment. Yeah. With air conditioning running. Yeah.
The air conditioning and the stove going,
Yeah.
or the water heater going.
Yep.
Then computers that might be charging right now, etc.
Then also in here, there's other, there's all the charge controller, the MPPTs that we were talking about, and they're all listed here, and you can go into each of them.
Each one is showing, so there's variations between these.
Yes.
And why?
So, yeah, most of them are over the 400 watt range as a
So
couple.
those are the upper flybridge panels.
Most likely, or it could be the left or the right-hand side of the boat, depending on where
Slightly
the sun is.
Right?
So,
Because they're tilted in opposite directions off the flybridge.
yeah, there's a bit of an angle to them. So, the ones that are maybe like 140 watts, those are probably in the shade right now.
And knowing that living with the system, those are the ones that are actually tucked sort of closest to the stern of the boat, where there's a little bit more shading on the rear cockpit system. So it goes roughly to double, and then the furthest point, or the two panels that are absolute stern of the boat, they're almost identical to the
rooftop ones.
Rooftop. Yeah.
And as you can see right now, the sun's coming out. You can see the numbers are coming up.
Wow. Look,
Significantly.
1,089. So that's 1,100 watts. It just popped in, right?
And
540. So that hit almost max.
Yeah, that was 100%.
At that point. Yeah. It was interesting that the system really works well.
Yeah.
Yeah. And if you go back
To the pages.
so it's about 5,000 watts right now.
Yep.
And we've seen upwards of 7,000 before. So the system is really working. I really didn't need to turn on the shore power. But let's see, this is the remote system. Let's see if I can get that to work. Right. So this is what I can basically be anywhere in the world and hit it. And it has two systems, right? We talked about the 12-volt system, which is running at 100% capacity, or 100%. It's at idle now, but it's consuming 195 watts, right?
So no, it's getting
well, the 12-volt system is consuming
correct.
191 watts right now, which in turn it's being inverted down and being provided by the inverters, or from a charger specifically, right? That wattage, right? To because it's in charge mode, right? And if we go back from there, now we can look at that, but you can see I've left it that way for a long time. Every once in a while, I'll turn that off just to let it cycle, because you want to maintain the health of the boat. Now, this is almost exactly the other system, but just in a different presentation.
Yep.
Right? And you can see that it's a cloudy day, so it's taking some of that data, right? It's got 46 amps of input from the shore, which is the limiter that we did. We didn't want to, we wanted it to be limited from the 50 amps just by a little bit.
Yep.
Yeah, and you can see it's actually 10,000 watts right now, so that's 50 amps. Yeah, in essence, so
pretty much the 46 amps. Yeah,
46 amps. Yeah, right. So we got the power coming from the solar and the existing charge. What's interesting is this is for the past 48 hours. Right. So over the past 48 hours, we went from, let's see, 90%, right? Because the day before, actually, it's been almost 3 days of consistent sun. I haven't been charging it for 3 days. I've been tying to shore power.
Yeah.
So you can see the consumption here. The low point yesterday, or 24 hours ago, about the same time, was 57%.
Yeah.
And that it was you can see the power versus consumption, or production of solar versus consumption. We went to 78%.
Yeah.
Right. From, what was that? 58, 57.
Yeah. Something like
or
that.
something like that. And now last night we ran down because it was a little cooler. So you were starting to see a little bit of spikes. That was a heating mode. Right. Which is interesting off that. So now we're at low point, but with sun, it's going to start producing again. But in about, I don't know, a couple hours from shore power, we'll
couple hours. Yeah, you should. If we leave shore power running, we're going to be charged up here in probably 2 hours.
Yeah, cool little system. And that basically, I can then go to remote console.
When what's cool, I'm going to push this off to the side so that they can see that it then mimics. So what you do on here, as you say, even though you could be sitting in Tokyo or London right now, and you have full control of the system on the boat.
Right. So let's try that, right? We got the quattros going at full tilt. We know it's on the bulk, so if we go to the switch, it's automatically, and it's giving me the choice. So if I put it back to inverter only, there it goes. So I'm going back to solely producing electricity from the solar power plant.
Yep.
So into inverter only. Now They're both the same, right?
Might be a little bit of a lag.
A little bit of lag because this is going up through the Starlink,
Yeah.
back down and communicate.
Yep.
Right?
Yeah, that's versus
That's real time.
Yeah.
Very cool. Very cool system.
Very, very cool.
All right, so we just showed the servo system and basically the inner workings of this. Why don't we show some of the parts and pieces that you were able to optimize in here? So we start with
Let's start down in the floor over here where we have the battery management BMS module, along with some snacks.
some snacks where we just started provisioning the boat for the Great Loop. So that's
over here, the MG device, that is the battery management system. That is the BMS. That is basically the safety feature of the system. It is there to protect the batteries as well as the boat.
Yeah. And what you don't see behind that is another series of distributors, and then the behind that wall right there is the other distributors, right? There's essentially are the bus bars.
Yeah, the big bus bars and the fuses for all safety reasons.
Yep.
So that's kind of where all your heavy gauge wire.
The important part was the green dot, right?
Yeah, the green light status means green is happy.
Yeah. And you can see the cabling is pretty hefty there.
Very hefty cabling, and as you can see, all labeled specifically where it's coming from, where it's going for future troubleshooting. And that then matches the drawings that Curtis has as well. So, if he does need someone other than Maz Ocean to troubleshoot this, say he's up in New England, someone up there could use those drawings.
I think I'm calling you saying help. We're going to go down the steps and open up another point of access.
Was in here. And I did ring a flashlight.
Let's see if I can get that in. There we go. So what is that?
All right, so on the top there, all the blue cam type looking things are the MPPT devices, but directly in front of you are two breaker boxes. Once again, safety. So we've got breakers on the input side of each MPPT and a breaker on the output side of each MPPT.
Beside that are those shunts.
Those are the bus bars.
Those are the bus bars. Okay.
Yeah, so basically all the MPPTs go to those bus bars, and the bus bars then go to the distributors onto the battery.
And then there's some other ones, I think, underneath here as well, because there's 7 of those, and those are right there.
Yeah,
right.
I believe so. There's a couple down there. Yeah.
And then there's actually the communication.
Yeah, the USB communications over there.
Right there.
So that communication gets to the servo that we've been looking at.
Yep. So this actually is 4 of the
MG batteries.
4 of the MG batteries, and then there's 2 more underneath the bed. But those are all shoved into the bowels of the boat.
Yep.
Right? And you had to custom build a platform in there to make that happen. And then you built mock-ups, right, in cardboard to make sure all this would fit and tie down.
Yeah, it was initially when we were trying to figure out where we were going to fit all the batteries. Was one of the interesting parts is that we're not 100% sure. Yeah, tape measure kind of gave us a pretty good indication it was going to be a tight squeeze. But we actually, as Curtis said, took some cardboard boxes and actually made up some fake batteries to make sure they were all going to fit.
Yeah, that was really part of the job, right? That was the key part of why figuring it out how to make it happen. All right, we are actually in the other side of the port side, and there is a whole bunch of cabling and wiring, but then underneath, I don't know if you can see it, is main breaker boxes.
Yeah, some, I believe, for the 8, I'm not even sure, I can't see it. It's just a basic box with some communication and that type of stuff, just a general communication little box.
Tie into the BMS.
Battery management system, yeah, correct.
Very cool.
And then we have 6 batteries on this side as well.
Yep. Underneath the bow, same spot. So this is the rear cockpit that we described, which is 6 of the panels, which we worked together with the JC
Marine, yeah, that did all the steel fabrication.
all the fabrication,
And built the whole arch or frame over here for the 6 panels.
and then added the outdoor showers integrated to it as well. Those are how do you balance not over engineering it and making it really, really sturdy for the boat, right?
And it also provides shade and protection for the dinghy,
Which was
a key added bonus.
that's part of it. Yeah, it's about living on the boat, making it very livable. So what do we got up here?
Up here is another 8 panels, 4 on port, 4 on starboard. As you can see with the overhang, and as we discussed the bifacial nature of the panels,
They're producing a lot.
because of the reflected power, as Curtis was saying, I think we're probably in the middle of summer going to see over the 7,500.
It'll be
watts.
really cool. I'll let you know.
Yeah, I'm looking forward to hearing that we're getting 8,500 or something like that.
Let's walk through the front so they can see the slight differences here.
Yeah, now take a look up top there. You're going to see the 2 sides, 4P starboard.
So they're mirrored right down the center of the boat.
Yeah.
So sometimes if it's sunny on one side versus the other, you'll see the difference between this sets of panels, which are broken into, because there's 4 on either side, 2 sets of 2.
Yeah, 2 pairs per side. So
I gotta ask the question.
Yeah.
After all this work, right? We started June, July of last year. It's now March, and beginning of April.
Yeah.
Right? What you think from concept to end?
yeah, it's been quite a project and an exciting project. I think a very successful project, and we pretty much achieved what we were, if not exceeded, what we were trying to achieve.
I can't thank you again. It's been a pleasure working with you, and thanks for explaining this to the kids and everybody.
Anytime.